Now our next speaker is Saurabh Dhakad, who is doing PhD with me. He will speak about integrating satellite observations for understanding chlorine chemistry and tropospheric ozone. He just he has started this work. And Saurabh,
Good afternoon, everyone, and thank you for being here till last of this session. My name is Saurabh Dhakad, and I'm a PhD scholar and working with Professor Umesh Chandra Kulshrestha. In this talk, I will be focusing on the chlorine chemistry and its importance in the tropospheric ozone dynamics. I did this study in Delhi. So let's start with some news pictures, which is showing the pollution pollution problem in Delhi, and these news are highlighting that Delhi is one of the most polluted city in the world. And here you can see some pictures which are showing the uh, pollution sources and the impact of health also. Uh, in last year, 24 December, Delhi was the one of the most polluted city. So in this slide, you can see the number of deaths associated with the air pollution worldwide. So this show the severity of this air pollution problem. Here are the some sources and uh, pollutant associated with them. You can see this slide shows the different sources and their contribution to PM 2.5 and PM10. Here you can see that transport and industries are the major sector which are contributing to PM 2.5 and 10. And also biomass burning is also contribute a lot to PM 2.5 and PM10. Uh, in this talk, I will focus on the chlorine aspect, which is not highlighted yet at that scale. We when we discuss about the chlorine tropospheric ozone chemistry, we discuss about NOx and VOCs and how they are affecting the ozone concentration. But there is also chlorine, which is not just limited to pool disinfection. It has very important, very significant role in the atmospheric chemistry. Chlorine mainly emitted from many natural and anthropogenic sources. Here in this picture, you can see that chlorine uh, impact the ozone by many ways. Like it can deplete the ozone or it can increase the concentration of ozone. Mainly in stratosphere, it mainly chlorine from CFCs, it deplete the ozone concentration, but in troposphere it can act like in two ways, like it can increase or decrease the ozone concentration. In Delhi we studied at a site, we observed PM10 2.5 and ozone concentration while doing analysis of particulate chloride and chlorine species, chlorine gas. We analyze the impact of chlorine on the tropospheric ozone. We've got some very interesting results. In We analyzed this chlorine and ozone for both daytime and nighttime. We found that when chlorine particulate chloride is increasing, then we notice some ozone dips uh, at that time, and this was also for gaseous chloride. So that was very interesting. So further, we analyze the impact of other parameters on ozone like PM 2.5, PM10, and temperature. We got very interesting results. Uh, so we noticed that in Delhi, uh, while chlorine concentration increasing, it decreasing the ozone concentration because it is just hitting the chlorine radical is just directly hitting the ozone and decreasing its concentration. It there can be two type of reaction. One can be chlorine radical can enhance the NOx chemistry and can increase the ozone. But in case of Delhi, due to high particles, high aerosols, the visibility is very low, and this NOx chemistry does not work. So ultimately, it is depleting the ozone. So it is very uh, interesting to understand further the impact. So for to understand the impact, this impact on large area, ground based measurement is not sufficient. Then for that we have only few satellite. We have only few satellite which provide some chlorine species data. So ground-based measurement should be linked with the satellite data to understand the better the its impact on ozone. We here we can have some planning that we can detect some chlorine containing species, and then we can monitor the ozone and its precursors. Uh, so we can identify the chlorine emission and sources, and we can further understand daytime and nighttime chemistry for better understanding, and we can monitor long range transport of chlorine species, chlorine influencing pollutants. We have some satellite products, like we have instrument like Tropomi, which can provide ozone and its precursor data, and MOPIT for carbon monoxide data, which is also a precursor to ozone formation, and MLS and MODIS data for some of the chlorine species, and to get the EOD data. Further, we can identify the sources which are containing chlorine to get better understanding. So here is the summary of my study, that chlorine and chloride are important species to measure in air for better understanding of tropospheric ozone chemistry, along with NOx and VOC's chemistry. Black carbon and Cl2 and chloride ratio are associated with fine particles. Ozone chemistry is also influenced by chlorine, chloride, and black carbon and total PM 2.5 particles. So need for important intensive studies on this aspect in overall Asia Oceania is needed. Chlorine emission inventory for this reason is highly recommended for better understanding. So thank you.
Thank you very much, Saurabh. And this is definitely new area where we have to focus on chlorine cycle in this region. So also it highlights need of more sensors, satellite sensor for chlorine species.